Okay guys, we're going to work through 6.1, day 2. We are working on number 4, 11, 19, and 20. Number 4 starts out which expression does not belong with the other three, and then we just need to talk about the reasoning behind it. So we have a to the 1 over n, and then we're going to raise it to the power of m. When you're raising a power to a power, you can multiply the exponents. So a to the 1 over n power multiplied by the m power will give you 1 times m is m, n times 1 is n. So a to the m over n power. A to m over n. When we look at over here, you can see that n is the root, so it's going to be the denominator. M is the exponent, so it will be the numerator. So you're going to have a to the m is the numerator, n is the denominator. A to the m over n, a to the m over n. Hopefully we're seeing a pattern here of matches. This very last box over here is also a to the m over n, so that's already done. We know now that this is the odd one out, and all we need to do is explain our reasoning behind it. There are two reasons that this is different. One, m is the root here, and negative n is the numerator. So a to the negative n over m. And you can already see that that's different. This is m over n, and this is n over m. But we also need to do something with this negative sign here. To do something with a negative sign, we're going to move it down to the denominator, the whole expression. A to the n over m is what that equals. So this right here, you can see it's different for two reasons. One, there's a negative exponent. And two, the n over m versus on the other ones, they are m over n. So both of those reasons are what makes this one different. Next one we need to do is number 11. Number 11 says we need to evaluate the expression. Whenever you see this word evaluate, we are talking about a number answer in this type of problem. You want to get a number out of this. So we can convert this into radical form. If we want, we can say 6th root of 64. In other words, 1, 2, 3, 4, 5, 6. What number, if we multiplied 6 of them together, would give us 64? And the answer here is 2. 2 times 2 times 2 times 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. 16, 32, and 64. So this whole thing, 64 to the 1/6 power, which equals 64, the 6th root of 64, all of that simplifies down to 2. That's your final answer. We also wanted to tackle number 19 and 20. Number 19 says, describe and correct the error. Alright, so I've got 27 as my base, and then I have 2 in the numerator position and 3 in the denominator position. The denominator here, the bottom part, is your root. So 3 is the root, and 2 is the exponent part. It's in the numerator position. It's the exponent part. So like this. If we wanted to take this to match the line here, we could say, okay, what is this expression? And that would be 27 to the 1/3 power squared. So we've got a match here. We're good on that. Let's take the cube root of 27. What times what times what equals 27? Well, the answer here is 3. 3 times 3 is 9. 9 times 3 is 27. So this entire expression, all of that, simplifies down to 3, and then it will be 3 squared. And that's this line right here. We can see that it's 3 squared, and this student wrote 9 squared. So there's the error. Let's correct the error, and then 3 squared equals 9. So that should be the final answer. The error here, student took the square root instead of the cube root. And let's make sure, did the student take the square root? The square root of 27 is not 9, so they divided by 3 is what? 27 divided by 3 is 9. So the student divided by 3 instead of the cube root. Divided by 3 instead of taking the cube root. Good deal. Now number 20, we have 256, and then we have 3 over here in the root position, and then we have 4 over here in the exponent position. So 256, the 3 is in the root position, and the 4 is in the exponent position. Let's match it up, and we can already see that this is the problem right here. The student put 4 in the root position, and the denominator is 3. So the denominator is always going to be your root, and this is where they messed up. If your denominator is 3, your root is 3. If the numerator is 4, then your exponent is going to be 4. So that's not going to work out for us. And we can finish this out to say that the cube root of 256, and then we would raise that to the 4th power. So 256 raised to the 1/3 power is 6.3496. So 256 raised to the 1/3 power, and then raised to the 4th power. All of this together will give you 256 to the 1/3 power is 6.3496. We'll raise that to the 4th power, and that is going to give us 1625.500 as your final answer. Now we'll take a look at numbers 21, 27, 28, and 40. The first thing they ask us to do is describe the transformation and then graph each function. So to describe the transformation, I'm starting with f of x is the cube root of x, and then I'm moving into negative cube root of x minus 1. So I see 2 translations already. Here's the first one. That's different. They added on a negative sign. And then they also put this negative 1 at the very end. So those are my differences. My first translation is going to be a reflection in the x-axis. That's this negative sign right here. The second translation is this one over here. My negative 1 is outside of this cube root grouping. So it's not going to affect the x, it's going to affect the y. It's going to shift it down 1 unit. Let's go ahead and graph f of x first. F of x is the cube root of x. So you can make a little table off to the side, a little xy table. The cube root of negative 1 is negative 1, because negative 1 times negative 1 is positive 1. Positive 1 times negative 1 is negative 1. The cube root of 0 is 0 for the same reasons, and the cube root of 1 is 1. 1 times 1 times 1 will give you 1. So we're going to graph those 3 coordinate points, negative 1, 0, 0, and positive 1, positive 1. Your cube root function will follow the same pattern as your cubic. So it's going to start low, and it will end high. The next function that you're going to graph is negative cube root of x minus 1. When you do that, you can always just pull up your table by pressing Control-T on the Inspire, and you're going to get your 3 coordinate points. The first one that you've got is negative 1, 0. You're going to have 0, negative 1, and then 1, negative 2. So So we're going to graph those points, and you will get -1, 0, 0, -1, and then 1, -2. And basically, you're going to take this point, you reflect it across the x-axis, which brings up here, and then you're going to shift it down 1 unit, which is right here. This one, when you reflect it across the axis, it stays put because it's the origin, but then you shift it down 1 unit. And the same thing here. You take this point, you reflect it across the x-axis, and then you shift it down 1 unit. Because it's this reflection, remember, it's not going to go low to high. It will start high and go low. So there you've been able to graph your two equations there. When we move on to the next one then, 27 says describe and correct the error in their graph. So I see that there are two translations happening here. The first translation that we're going to talk about is this -2. This -2 is outside of the square root grouping, so that is going to shift us down 2 units. The next one is -2 out here, and it is inside of the grouping, so it is going to shift us right 2 units. Here's your parent function. We know that it goes through 1, 1 as well, just like that. So let's make sure that each of these coordinate points is shifted down 2 units, down 2, and then we need to go right 2 units, out 2. It looks like this student, they went down 2, but then they went left 2 units, and that's the wrong direction. So it should be here and here. That's where it should be. So we corrected the error here, and now we just need to describe it. The student shifted right instead of left. The student shifted left, there we go, instead of right. The very last one is 28 and 40. We're going to do those two. So describe the error and correct it. Two transformations again. You've got the 1/2 in front, and then you have the +3. The +3 is going to shift you up 3 units. The 1/2 is a horizontal stretch. We know this is going to be a horizontal stretch because inside of the square root grouping there is a fraction. That's a horizontal stretch. Let's see what the student wrote. The graph of G is a horizontal shrink by a factor of 1/2 and a translation of 3 units up of the parent square root function. 3 units up is for sure happening. This horizontal shrink should actually be a horizontal stretch. So we're going to write that down here. The student wrote a horizontal shrink. It is a horizontal stretch by a factor of 2. Alright. Remember your horizontal stretches, you're going to take whatever that they give you and you're going to flip the fraction. Number 40 is the very last one that we need to do. It says write a rule for the transformation that they're describing. So we're going to start with this function right here. F of x equals 2 multiplied by the cube root of x minus 1. They want us to do a reflection in the y-axis. A reflection in the y-axis means that we're going to change the signs on the inside. After we change the sign on the inside, then we are going to shift 1 unit right of the graph.